Hey guys, my name is Shreyas and welcome to Simple Chemistry. In this video we're going to be talking about the origin of the mole. Now, you might have remembered from the first unit that the mole is a very unique way of counting particles, and there's actually more to the mole than that. It's a very special number actually, and we're going to be using it all throughout this unit, so it's going to be important to understand what this is and where it actually comes from as well. In addition to that, I would highly recommend that you go and watch the video on average atomic mass right before this and you understand that, because some of the things from that is going to play a role into this video here, and it's going to really help if you know the content from that video in order to help explain things in this video. Okay, so enough of the talking, let's get right into it. Okay, so scientists discovered this data point right here, that carbon-12 has, they set carbon-12, and again that's carbon which has 6 protons and 6 neutrons, has an atomic mass of exactly 12U, okay? And we talked about that in the previous video. And scientists also discovered this interesting piece of information, that 6.022 times 10 to the 23rd atoms, so a huge number of this number of atoms of carbon-12 have a total mass, so all of these atoms put together, 6.022 times 10 to the 23rd atoms of carbon-12 have a total mass of exactly 12 grams. Okay, exactly 12 grams. Now from this information, I'm going to show you how to get this information right here. Nitrogen has an atomic mass of 14.007 U. You can look at that on the periodic table and see that. And actually 6.022 times 10 to the 23rd atoms of nitrogen. So the exact number here, this number here is matching up with this number here of nitrogen, will have a total mass of, you can guess, 14.007 grams. It's very interesting. So let me show you this. How I'm going to prove this to you through dimensional analysis. So we're looking for grams, okay, and we're given that 12 grams of carbon is equivalent to 6.022 times 10 to the 23rd atoms of carbon. So 6.022 times 10 to the 23rd atoms of carbon, 12, by the way, of carbon-12, I'm just going to say C. 6.022 times 10 to the 23rd atoms of carbon-12 has a mass of exactly 12 grams. And we got that information from this first bullet point here, okay? Now from here, we can keep moving on. We also know that one atom of carbon, and this is carbon-12 by the way, I keep saying carbon, but I'm saying carbon-12, has an atomic mass of exactly 12U, all right? Now from here, one atom of nitrogen so from here we can use the fact that nitrogen has an atomic mass of 14.07007 U. Okay. And then the final thing we have is what's going to be the mass of 6.022 times 10 to the 23rd atoms of nitrogen. Okay, so look at this interesting thing here. So we use blue colors to cancel out the units. So for the units, atoms of carbon cancels out with atoms of carbon, atomic mass units cancel with atomic mass units, and atoms of nitrogen cancels with atoms of nitrogen. I didn't write atoms of nitrogen here, but that's going to cancel with atoms of nitrogen. And then another interesting thing here is that the numbers also cancel out. So 6.022 times 10 to the 23rd here is going to cancel with 6.022 times 10 to the 23rd here. 12 is going to be canceled with 12. And what we're left with is 14, this is going to equal 14.007 grams. Okay? And so what this is telling us is that 6.022 times 10 to the 23rd atoms of nitrogen is going to have a mass of 14.007 grams. And also, using the same dimensional analysis here, you will realize that everything on the periodic table here, if you have 6.022 times 10 to the 23rd atoms of that element, the mass, the total mass of all those atoms is going to be equal to the average atomic mass of the element. So for example, let me give you an example here. Let's say with nickel, if we have 6.022 times 10 to the 23rd atoms of nickel, the total mass of all those atoms is going to be equal to 58.693 grams. And this is an amazing tool that scientists have because they had all the average atomic masses, and now from here, they know that this interesting number right here, 6.022 times 10 to the 23rd, can help them find the ratio between the number of atoms and the mass that all those atoms is going to have. It's a very important thing. I'm going to be talking about that. Okay, so this number here, this interesting number that I keep saying, 6.022 times 10 to the 23rd, is called Avogadro's number. Okay. And when we say 1 mole of a substance, we're saying 6.022 times 10 to the 23rd. So basically, a simpler way of saying 6.022 times 10 to the 23rd is just saying 1 mole. Okay, let me write that down. 1 mole equals 6.022 times 10 to the 23rd. Okay. So what you need to take from this video is these things. 1 mole is 6.022 times 10 to the 23rd. That number is also called Avogadro's number. And if you have 6.022 times 10 to the 23rd atoms of any of the elements here, the total mass of that is going to be equal to the average atomic mass except in grams. Okay, those 3 points you need to take from this video. And once you got that, you're going to be ready for the rest of stoichiometry. The origin of the mole is as simple as that.